So far, we've learned how to factor monomials by writing out their factorizations and factoring out greatest common factors of polynomials. We'll begin with this lesson by looking at binomial greatest common factors. So let's look at our three examples. In example 1, we'll look and notice that our common factor of 4x and minus 7xy is x. So we factor out our common factor, our greatest common factor, and that leaves us with 4 minus 7y inside of our parentheses. And that's what we learned in that first factoring lesson. When we look at our second example, however, we'll notice that it looks a bit different. We still have two terms, but within each term, we have a factor that's a binomial. And we'll actually notice that the x plus 1 and x plus 1 are our greatest common factors in both of these two terms. So again, we're going to factor out our greatest common factor, but in this case, our greatest common factor is indeed a binomial. So we factor out the x plus 1 since they're common, and that leaves us with a 4 from our first term and minus 7y from our second term. And you'll see this is actually similar to our first example, except our common factor was a binomial. Looking at our third example, it's similar to our second one, where we have our two terms, but our common factor of each of these terms is m minus 2. So I'll factor out the m minus 2, leaving me with the m squared from the first term and the minus 3 from the second term. So now that we know how to factor out binomial greatest common factors, we can go ahead and apply this to a new technique for factoring that we haven't learned so far, and that is factoring polynomials by grouping. So we'll look at two examples here, and we'll learn how to do the grouping method for them. For example 1, if we're asked to factor this completely, we'll begin by looking for a greatest common factor, but we'll notice that there is no greatest common factor from all of the four terms. So what we'll try to do is, instead of factoring this as one big group of 4 terms, we're going to break this into two groups of 2. And we're going to try to factor each one of these groups separately. So in our first group, our greatest common factor would be 7x squared. And if we factor that out of our first group, we're left with x plus 2 inside of our parentheses. We do the same thing for the second group. We carry down our plus sign, and our greatest common factor of 4x and 8 would be 4. So we factor out the 4, and that leaves us with x plus 2 in the parentheses. And we'll notice, now that we've factored out greatest common factors from each group, we have a common factor in each of our two terms. The common factor is x plus 2. So we'll factor out the x plus 2, just like we did in that previous page, and that leaves us with 7x squared plus 4. Now we've factored by using the grouping method. Let's look at the second example and again try and use the grouping method. Because of these 4 terms, there are no common factors besides 1. So we'll make our two groups in parentheses, and we have to be careful with this negative sign in front of the 2a. We want to make sure that we include that negative sign inside the parentheses, so I'm going to make it plus the negative 2a plus 3. That way I don't get that confused. Now I'll factor out each of the two groups separately. I'll factor out a 5a squared from my first group, leaving me with 2a minus 3. Then I have my plus sign that comes next. I'm going to bring that down. And in the second group, the only common factor that I have is 1. And I'm actually going to factor out a negative 1 from this example so that my negative 2a becomes a positive 2a. I always want that first term to become positive. So if I factor out a negative 1, that leaves me with 2a minus 3. And again, we'll notice that I've got a common binomial in each of these two terms of 2a minus 3. So I go one step further by factoring out that binomial of 2a minus 3 from each of the terms, and that leaves me with 5a squared from the first term plus negative 1, which is just the same thing as minus 1. And so what you'll notice with the grouping technique is that it actually takes 2 steps in order to complete. First, you factor out GCFs from each group, and then you factor the binomial out of each of the 2 terms that you've created. If you think you've got the hang of it, go ahead and try the next 2 examples on your own by pausing the video, and then resume the video once you've attempted them. Okay, let's look at our 2 problems here, and we'll move a bit quicker since these are our 3rd and 4th examples. We'll group these 2 terms, and in our first group, our GCF is 3m to the 3rd, leaving us with m squared plus 2. And in our second group, our greatest common factor is going to be a -4. So we want to factor out a -4, and that leaves us with m squared plus 2. After doing that, we have a common binomial of m squared minus 2, so we do our second step. Factor out that common factor of m squared plus 2, and we are left with, in our second binomial, 3m to the 3rd, and then minus 4. We'll do one last example. Back to the example 4 by grouping. And I don't have to worry about the negative sign since there aren't one, so I can just put the parentheses right around them. In my first group, my GCF is 8x, leaving me with x plus 2y. And in my second group, my GCF, well, I only have one that I could factor out. So I'll go ahead and do that, using it as a placeholder for right now. And once I've done that, I notice that my common binomial is x plus 2y. So I factor out the x plus 2y, leaving me with 8x plus 1. So that's the grouping technique. Let's just cover a few more details about it. First of all, when would we want to use the grouping technique? Well, only after you've looked for all greatest common factors. That's always your first step. And usually you use the grouping technique when a polynomial has 4 or more even-numbered terms. So it works best if it has 4 or 6 or 8 terms, because you can break the groups evenly up into even-numbered terms. And let's look at one more question here. Will factoring by grouping always work? So let's look at an example to see if that's the case. If we're factoring the polynomial x to the 3rd minus 2x squared plus 6x plus 4, let's look for GCFs. But since there aren't any, we go ahead and try and use the grouping technique. From our first group, our GCF is x squared, and that leaves us with x minus 2. And from our second group, our greatest common factor is 2, leaving us with 3x plus 2. Now that we've done our first step, let's see if we've got a common binomial. We need x minus 2 and 3x plus 2 to be the same to do the next step. But since these binomials are not common, since they're different, we can't complete the grouping technique. So we are not able to factor this. And since we're not able to factor it completely, in other words, since there's still this plus sign in here, and we don't have it rewritten as a product, this polynomial cannot be factored by grouping. And so therefore, it's prime. So there are times where, even with using 4 terms, the grouping technique isn't going to work, and you still can have a prime polynomial.